Hello everyone, welcome to the next lecture on the PY question series. Today we will discuss about multivariate normal distribution. I will cover all those questions from the year 2009 to 2023. Myself Dr. Harish Garg. You can simply follow my YouTube channel. Here you can find the playlist of the CSRNet UGC GATE. You can see the various PY questions related to the different topics as well as from the statistics background like testing of the hypothesis, inner product, uniform convergence, reliability, Bayesian estimator, all are from the GATE as well as CSRNet examination. You can also see the complete Markov chain and many more in this playlist. So the objective of this, we will cover 30 plus question in this lecture only related to the multivariate normal distribution from this GATE December 2009 to 2023. So before I start with this one, so make sure the most important thing in the multivariate normal distribution is every time the question is asked directly based on the results. They are not doing much calculation in this multivariate normal distribution. The 95% questions are definitely asked related to the direct results. So you must remember the results. I can quickly recall some shortcut tricks which you can use them for solving the MCQ problems related to the multivariate normal distribution in a very simple manner. So let's say if I assume x is my p cross 1 real vector and this sigma is my positive definite. What does it mean sigma is the positive definite? If I say this is a11, a12 and so on, first of all the diagonal entries should be greater than 0, and every minors, like if I say this is a21, a22, this minor should be greater than of 0. This multivariate normal distribution is denoted as n is the multivariate, p is my vector, there is a multivariate vector, mu is called as the mean and sigma is called as the covariance matrix, fine, or sometimes called as the variance covariance matrix. Then if you have a multivariate normal distribution x minus mu must follows the again a multivariate normal distribution, but the mean is my 0 and the variance covariance matrix is same. On the other hand, as if in case of the univariate, what is the meaning of the univariate? If it follows the normal distribution here, then we all know x minus 0 divided by sigma. If I say this is sigma square variance, then this of square will follows my chi-square distribution with 1 degree of freedom. The same thing we can do like here. I can written this quantity x square I can written as in terms of vector here, sigma inverse is written as here, fine. Now same thing we can do like here. If x is my multivariate normal distribution and x minus mu transpose sigma inverse will follow the chi-square distribution with a p degree of freedom, where this p is nothing but my rank of this sigma. If you are unable to use this mu, then we call as the non-central chi-square. Why? Because what is the mean of the x? Mean of the x is my mu, and here if you simply use x transpose, then we call as a non-central chi-square. However, if we are using x minus mu transpose, where mu is the mean of this, then we call as the central chi-square transpose. So basically this is my central chi-square distribution. So once it has a non-central chi-square, then it has some parameter delta which is called as the non-central parameter, and this parameter is my mu transpose this of here. Another concept is if you have x is my multivariate normal distribution, then the sample mean is my, what is that? Sample mean is follows to be here. On the other hand, you can see x n times x bar minus mu will again follows the chi-square distribution of this. You all know in the univariate distribution what will happen. The univariate, it follows my sigma square divided by n, and you can see the same thing I can say x bar minus mu divided by sigma over root n. This will follows my standard normal distribution of 0 1, and if I square them, then it will follows my chi-square of 1, and if you square them it will be n in the upside. If you change p is equal to 1, then this multivariate normal distribution is converted into the single univariate normal distribution. If you have again a multivariate normal distribution and A is any symmetric matrix such that rank of A is my K, then again you can define X transpose AX is my chi-square, but in this case K is nothing but rank of A. So since rank of the A is my K, so it's a chi-square K. So it happens if and only if A is my idempotent matrix. On the other hand, if you have X is a multivariate normal distribution, if you take as a linear combination of Y, like say this is x1 plus x2, fine, then clearly say this can be written as 1 1 of x1 x2. So this is my C, this is my X, or if I say plus minus of this or any other combination of here, then you can define the C correspondingly. Then Y is again a multivariate normal distribution, but the parameter is rank of this C. So this is my Q, and C of mu is the mean of this, and the variance is my C sigma C transpose. Second concept which are used in the multivariate distribution is how you can check the vectors are my independent or not. If you have the multivariate distribution, sigma is my positive symmetric matrix, then AX and BY are my independent if and only if this results hold. For example, if I say Y is my x1 plus x2, Z is my x1 minus 2x2. How you can check where xi's are follows my normal distribution of this? How you can check whether x and z are independent or not? You can construct this A. So A is my 1 1, and z of this, the B is my 1 and minus 2. So if I substitute the value of A, sigma is my this into B transpose. If this is 0, then they are independent, and converse also true. If you have the multivariate distribution and X transpose AX, that is nothing but my quadratic form, fine. So now clearly say X is my mu, mean has mu, so this is the non-central. If it is follow the non-central chi-square distribution, and Bx is my linear combination, it's my linear form, then they are independent if B sigma A is my 0. This is the very important result. If X and Y are jointly normal distribution, the word is jointly is important, then the covariance 0 if and only if X and Y are independent. Always remember, we all know if X and Y are my independent, then this implies covariance is my 0, while converse is not true. Fine, while converse is not true. But when the converse is true, when you have the jointly normal distribution, while in case of the univariate distribution, this result does not hold. Similarly, if you are working on this rank of, if you have the two matrix A and B such that rank of A is K1, rank of B is K2, then we can define the two quadratic form of this, which follows my chi-square distribution with the rank of A. Rank of A is my chi1, this is my chi-square, rank of this is my K2. Since mu is subtracted, so these are my called as central chi-square distribution. Then they are independent if and only if these results hold. And this is same of this. The last result is when you have the normal distribution, Q is my quadratic form. How you can find the expected value of this matrix is trace of A and the variance covariance matrix plus mu transpose of this. So based on these simple concept, I can solve each question within a 10 second so that you can learn the various tricks. So let's start with this one. So first question is GATE December 2010. X is my normal distribution with the mu is here and sigma is my positive definite. Then which of the following is my correct statement? So first of all, what is that? This is my transpose, this minus here. So clearly says this is the central chi-square with a degree of freedom P, because it has a P. Now if I consider this is my Y, so what does it mean? Y follows chi-square of P. Then your required target is to find the value of this. Now since we are talking about the bounds, so which result you can use? You can use the Markov inequality. So what is the Markov inequality? Is greater than is always be less than of expected value of y divided by t. Now since y follows the chi-square distribution, what is the mean of the y? Is the degree of freedom. What is the variance of y? Is a twice of degree of freedom. So this is my p over t. So it's a less than p over t. B is my right answer. This is less than of t is a wrong. It's a greater than, so these are also wrong. Right answer is only my B is the right answer. And you can see based on this simple straightforward concept, you can solve this within a 10-second answer. Look at this another one. It's a December 2011. X follows my normal distribution, multivariate normal distribution I of P, where I is my identity matrix, A is my real symmetric matrix. Fine. Then X transpose AX will follows chi-square distribution. Fine. With a degree of freedom P. Look at that. This is a 0. So this is a central, because X I can return this quantity also as X minus 0, A X minus 0. When it will be here, if the rank of A is my P, or the rank is not there, or if it is a K, then it will be K. If and only if A square is equal to A. But he said converse is not true. That is a wrong answer. X transpose AX is a chi-square distribution. If and then he said this follows chi-square distribution, then the degree of freedom is my P. What is that? The degree of freedom is my rank of A. But what is the A? A is my symmetric matrix. So symmetric matrix may not have a rank of the P. It may have rank of K, which is less than of P. So it is not always equal to P. X transpose AX is a chi-square distribution. Fine. Then the characteristics roots. What is the characteristics root is? That is called as eigen value. So if I say this is a characteristics, this is a chi-square distribution with K, then K must be the sum of the eigens values of this one. What is that? This is my eigens value of the matrix A. Eigenvalue of the matrix A. So what is the eigenvalue of the matrix? He said only 0 and 1, but it's not true. If I say 1, 2, 0, 0, it is my symmetric matrix. Fine. And so clearly say the eigenvalues are not 0 and 1. So this option is cancelled out. X transpose AX is a chi-square distribution. Then X is necessarily be a positive definite. That is the correct statement. And you must remember this is also one of the result. Whenever X transpose A is follows the chi-square, then it is a positive symmetric matrix. So you can see the positive definite is missing in this case. So that's why this is a right answer is only D is the right answer. X1, X2 and X3 are my independent. Then which are this is my quadratic form. Fine. So firstly we can define this covariance matrix. How you can define that? You have a three variables. Now X1, X2 and X3. X1 and X2, this is a variance. What is the variance of X1 into X2? Is a 1. What is the covariance of X1, X2? Now since they are independent, so this value is my 0. Similarly X1 and X3 are 0. X2, X1 is 0. X2, X2, that is a variance. Variance is my 1. This is 0, 1, 0 and 0. So what is that? Basically this is my identity. Rank of this is my 3. Now you can see I can return this number as X1, X2 and X1. So X1 plus X2 square divide plus 2x3 square divided by 2, and this value I can return this as over 2. Now you can see I can return this value in this form plus x3 square. Now what is that? X3 follows the normal distribution, so x3 square will follows my chi-square distribution 1. Now x1 plus x2 it follows the normal distribution. What is the mean of this? 1 minus 1 0. x1 and x2 are independent, so the variance will be 1 plus 1 2. So I can written this as x1 plus x2 minus 0 divided by root 2 square. This follows my chi-square distribution 1. So this is my chi-square distribution, this is my chi-square distribution, both are my independent. The sum will be my chi-square distribution of 2. And since mean is already subtracted, so this is my central chi-square distribution. Q1 is my central chi-square distribution. Look at this, Q1 minus x1 minus x2. It follows my normal distribution. The mean is my 2. Variance is my 2. So what is that? x1 minus x2 minus mean over root 2. This square will follows the chi-square distribution 1. But we have this value. So this is not chi-square distribution. Anyhow, now since this, I can also written this number as this divided by root 2. This is also the chi-square distribution, but because mean is not subtracted, so I can say this is the non-central chi-square distribution. But Q2 he said is a central chi-square, is a cancel out. Q1 plus Q2 is a central, again is a cancel out because it is not a, Q2 is not a central distribution. Q1 and Q2 are independent. How you can check about the independent? Again, a very simple. So as I tell you, what is the shortcut to is, if you write this, the corresponding matrix A, how you can write the corresponding matrix? What is the coefficient of the x1 square? Half. Coefficient of the x2 square? Half. Coefficient of the x3 square is 1. x1, x2 is half, half, rest values are my 0. Similarly, I can write for the B, coefficient of the x1 square half, coefficient of the x2 square half, coefficient of the x3 square 0. This is my minus 1, so I can return as of this case. Fine. Now when it's said to be this, when you have this value should be 0. So you all know quadratic form Q1 and Q2 are independent if and only if A, this is my 0. Now since sigma is my I, so what does it mean? If you simply prove AB is my 0. Now what is that? If you multiply first row with the first column, half 1 by 4 minus 1 by 4, 0. Half 0, 0, 0. Again 0. This into this, third, this 0, 0, 0, 0. So clearly says A, X, Q1 and Q2 are independent. The right answer is A and D are my correct answer. You can scan and join my WhatsApp group if you feel it's very important for you. We can discuss various problems in this group as well. Okay, look at this one. X1 follows normal distribution, X2 follows normal distribution, P1 is greater than P2 are the positive definite. Then, so first of all, if this follows the normal distribution 0, comma, and your target is to this. So since it's a 0, I can return this number as this sigma 1 inverse x1 minus 0. It follows chi-square distribution with P1. Fine. Now you can see this is not a P, is not a chi-square. Similarly, I can return this is x1 transpose x, this it follows my chi-square of P1. Similarly, x transpose 2, this is x2, again it follows the chi-square distribution with the P2. Then what is that? Sum of the two chi-square distribution is again a chi-square distribution, while with degree of freedom is sum of this degree of freedom. So you can see this is my correct. Difference, this is wrong because it's not the inverse. Difference of the chi-square is also chi-square, but this is a non-central distribution, but it is a central distribution, so this option is cancel out. Now when the F distribution will be hold, when a ratio of two independent chi-square distribution divided by degree of freedom, then it is called as F distribution. Now look at that. What is the degree of freedom of this? So it means x1 transpose divided by p1 divided by x2 transpose divided by p2. It follows my F distribution with a p1 and p2. So you can see if I solve this, it's a here this is a p1, but I needed a divided by p1, so this property is not satisfied. I can say this will follows p2 comma p1 because I can return this quantity as divided by p1 and here. So this is wrong option. Correct option is only my B. So this is the correct way when p1 and p2 will be followed. Look at this another one. If xi's are my normal distribution with 0 comma sigma, L is my here and so on. How you can think about this one? Again a very simple. Okay, first of all, what is that? If x into x transpose will always follows the V-stars distribution. This we will cover in the next topic, but I will tell you in advance what is that. This is called as the V-stars distribution, and this n is my degree of freedom. Fine. Now you can see if I call this is my m, then m follows my V-stars distribution with here. So you can see this is my V-stars distribution. Then expected value of the m is n into sigma. So now you can see if I say this number is my V-star distribution. So what is that? If I look about this number is my A is n into sigma. Fine. So you can see the last option is cancelled. You can see about here. So from this L is a vector which is independent of I can take is outside. The remaining part is, if I consider this number is my m into L. So what is that? E of m is n sigma into L, which is a C. But you can see he said C is equal to this is again the cancel option. Now look at this another one. Again, what is that? This is my V-stars distribution. So L transpose m into L. Fine. Now you can use the tips for you. If L is any vector, then L transpose m into P will follows the chi-square distribution. Here is a L sigma of L. Now it follows the chi-square, but this is my constant vector, and we all know if x follows the chi-square distribution with the degree of freedom n, if you multiply by alpha, this follows my gamma distribution. Fine. But he said he follows the chi-square distribution, so this option is cancelled. Only correct option is my, which is the left behind, C is my correct answer for this problem. This is the first way you can solve this by using the V-stars distribution. There is one more method. Instead of using the V-stars distribution, you can use the multivariate normal distribution. Here I can choose n is my 2 for the easier calculation. Then what is that? This value is my x1 square plus x2 square, which is nothing but a. Now what is that? Because I can return this value as x1 square plus x2 square is my a. Now you can see what is the e of x1 square, which is variance of x1. This is variance of x2, because mean is my 0. Now clearly says this is my, if I call this is my sigma any element here, so a will be my twice of this. So again this option is cancelled. And you can see if you are using the V-stars distribution with here, if I call this is my m, then again you get n is this number. Here n is my 2, so you can see the same answer. Now again you can see by using this option how you can solve that. I taking n is my 2, so what is that? This is L x1 square L plus L x2 square L. So what is that? L square will be a common. E of x square plus y square is nothing but my 2 of sigma, which comes to be C. So now clearly say C is not equal to L transpose L. So this option is also cancelled. Now how you can think about this? Now since if I take N is my 2, then this value will be my L square, x1 square plus x2 square. This will follows the chi-square distribution. So x1 square plus x2 square will follows my chi-square distribution with the 2 degree freedom, but L is my constant number. So if you multiply this here, then it follows my gamma distribution. But he said is a chi-square distribution cancel. Again, the correct option is my C is the right answer. And if it's a gamma distribution, the degree freedom will be my if 2 over 2 and 2 times L square. These are the parameters of this. Now look at this another one. If x follows here, rank is my k. Okay, then you need a x transpose ax and you need a x transpose x. Okay, x follows my normal distribution with a 0, I, means your sigma is my identity. This will follows the chi-square with the degree freedom. What is the degree freedom is? Rank of A. So what is the rank of A is? K. What is that? I can return this number because this is here. So I can return also this number is this. This follows the chi-square distribution with degree freedom P. Fine. Now the 2 degree freedoms are given to you. Now but you can see they have used the same x. So it means they are dependent to each other. But always remember x over y, if x and y follows chi-square distribution with the degree freedom k1 and k2, if they are independent, then it follows the f distribution. Then this divided by k1, this divided by k2. But now you can see they are not independent, so f distribution is not applicable. If you think about like this way, that x transpose ax divided by k, and from here you can say x transpose x divided by p, that means k of p. I can multiply and divide, so this follows k by p of f k by p. Then according to you this is the correct option. But remember, this ratio is applicable only when they are independent, but they are not independent. Similarly, f is cancelled out. Now what will happen? They are dependent. So if x and y follows the chi-square distribution with k1, chi-square distribution k2, and they are dependent to each other, then x over y follows beta distribution with the degree of freedom k with parameters k1 over 2 and k2 over 2. So in this case the first parameter is k, second parameter is p, degree of freedom. So k1 over 2 and p over 2 is the right answer of this problem. So C is my correct answer of this problem. There is one you all know, if they are my here, then it again follows the beta distribution with the parameter degree of freedom of x and degree of freedom of the denominator. Fine. Again they are to be independent, but here they are not given, so the right answer is C is the correct option. Okay, look at this one. Which of the following is my, okay, again you can see this quantity is here where y I follows normal distribution with here, then clearly says summation of this value will follows my v star distribution with the degree of freedom. What is the n is 10, so it's a 10 comma sigma. Fine. Again this is my Vsart distribution. Now then A is any real vector, you have to find of the inverse. Okay. So now I can simply tell you, if X follows the normal distribution with the parameter mu sigma of this, then always remember this simple tips. A transpose sigma inverse A divided by A transpose A inverse of A. It follows the chi-square distribution with the degree of freedom n minus p plus 1. So if you look about here, A is my 2, 1. Fine. Sigma is my 3, 0, 3, 0. I need the sigma inverse. So what is the sigma inverse? So it's a diagonal matrix. So inverse of this is my here. Then I need the denominator part. Fine. I need, so what is that? This is chi-square n. N is my 10. P. What is the P is my 2 plus 1, which is chi-square of 9. But he said chi-square of 8. He said not a chi-square. Now whether it's a central or non-central. Since the mean is 0, so it is a central. So this option is cancelled. Right option is my here. We will see whether 5 over 3 appears or not. So what is the A transpose? Sigma inverse of A. So 2, 1. If I multiply this by 2 into 1, so it's a 6. And so it is already a transpose. Otherwise matrix multiply is not possible. So it's a 2 into 1. It's a 6 and 3. Sorry, I have to multiply this 2 into 1. So it's a 2 over 3 and 1 over 3. So what is that? 4 over 3. So it's a 5 over 3. So I can substitute the numerator part is 5 over 3. Denominator part I can return this number as A inverse. It follows the chi-square of 9. So the right answer is C is my correct option. You can see in the multivariate normal distribution, always remember the result which I have mentioned in the first 5 minutes. I have used the same result. Nothing is to be used the calculation. Okay, look at this one. If xi follows the normal distribution with the p variate, mean is my mu, variance covariance matrix is sigma. With a positive code, which of the following is my true? Fine. So what is that? x1 minus mu transpose sigma inverse. This will follows chi-square distribution with the degree of freedom p, but first question said is a 1 degree of freedom. X transpose x bar will follows my normal distribution with the mean is mu, variance is sigma by n. Now x bar into x transpose, which is the same of y into y transpose. Fine. This is normal distribution with the parameter p, degree of freedom is n because it has a size of the n into sigma. Sigma is my this case. Now what is that? Is a how many? What is the degree of freedom? This is my degree of freedom. This is my scale parameter. Fine. So the degree of freedom is n, but he said p. This option is cancelled. Look at this another one. What is given to you? This. Now in this case you can see sigma is missing, but what is that? I can see again this value is nothing but xi. Okay, I can say xi minus mu. It follows my normal distribution with 0 comma of this. Then if I consider this is my y, then this quantity is my y into y transpose. So this is follows my v star distribution with the degree of freedom. Summation is my n and mean is my sigma. Then it has a v star distribution with the n degree of freedom. You can see this is a n degree of freedom. This option is correct option. Now check whether these are independent or not. How you can check the independent? I can find the covariance x1 plus x2, x1 minus x2. So if I open them, it will be covariance x1 x1 minus covariance x1 x2 plus covariance x2 x1 and minus covariance x2 x2. So I can return here. Fine. So what is that? This is variance of x1. This will be cancelled out, minus variance of x2. So what is the variance of x1? Since it is a covariance matrix, so you can choose any value. So say 1, 2, 0 and 0. This is my positive definite matrix. So what is that? 1 minus 2, which is non-zero. And for the independent, as I told you earlier, covariance must, if covariance is non-zero, what this means? They are dependent. So they are dependent. So this option is cancelled. There is one more method how you can check about the independence. If you remember my earlier shortcut tricks, you have to return this number should be 0. What is my A? The coefficient matrix 1, 1. B is my 1 minus 1. So I can start with here 1, 1. Sigma is my nothing is given to you. So I can choose as A, B, C, D and 1 minus 1. So if it is a positive definite, I consider this as a 0. So what is that? It is my 1, 1 and then A minus of D. So clearly say this is a A minus, which is not always 0. Fine. So if I consider this 1, 2, 0, 0, again it's a non-zero. So the right option is C is the right answer. Okay, T distribution. Fine. When it will be follow the T distribution, there is a Z variable divided by chi-square of degree of freedom n. Then it follows my T distribution with the degree of freedom n. And make sure both these ratios are my independent variables. Fine. This Z and X are independent. Xi's are my standard normal distribution. So X, now you can see X1 and X1, so they are dependent. So it is not following the T distribution. X1, X1, again a T distribution not follow. Now they are independent, X1 will follow the standard normal distribution, fine. X2 square will follows my, what is that? It follows my chi-square distribution with a degree of freedom 1. What does it mean? X2 square plus xn plus 1 square will follows my chi-square distribution. How many elements are there? N. Now, what does it mean? If I say x1 square root of this x2 square plus xn plus 1 square divided by degree of freedom, it follows my T of n degree of freedom. So root of n I can written upside. He said n minus 1 degree of freedom. This option is cancelled. He said n degree of freedom. This option is correct option. A and B option you can discard it directly because they are not independent. So but C and D are independent, so you can check it by on. Now look at the next one. If X and Y are my joint distribution such that X follows my normal distribution of 0, 1, then expected value of this, okay, a simple, your target is to find the covariance of X, Y, which is XY minus EX, EY. Fine. EX is my 0 from here, so which is of this case. Now how you can find the X? Clearly says they are not independent. Fine. And we all know expected value of X condition Y. If I again apply the expected value, it is my expected value of the first quantity. Now I can use the same concept. Here Y is my dependent, so I can return this value. How you can return this value? I need to be Y condition X. Fine. So I can return this is XY condition x. Fine. Again, by using this, whatever you have written here, the same thing which can be written this. Now, how you can written this value? So this is expected value of E of x is outside, expected value of y condition x. What is the expected value of y condition x? It's x cube. So what is that? This is E of x raised to power 4. Fine. Now that's over. What is the expected value of the x4? Where x is my standard normal distribution. So we all know expected value of the odd numbers always 0 for all n, while expected value of the even numbers, which is my 1, 3, 5 and up to 2n minus 1 into sigma square, sigma of the x. Now you can see from this case n is my 2. So if I substitute 2, it will be 1 into 3 into variance of the x. What is the variance of the x? 1. It is a 3, which is greater than 0. So the covariance is my greater than 0. This option cancel, this option cancel. Now since variance is my non-zero, so you can't say that they are independent. They are dependent. You can also see that they are dependent. Look at the next example. X and y are my random variables such that marginal of x, marginal of y are my normal distribution. Okay. Then which of the following condition implies? First option is definitely discard. Why? Because he said covariance is a 0. This implies x and y are independent. So this happens only if x and y are jointly normal distribution. Fine. But you can see these are the random vector. They are not given that they are jointly distribution. So first option is cancelled out. Ax plus by, okay, are normally distributed with the mean, and here Ax plus by, he said it's a normal distribution. The mean is, what is the mean of this? 0. Variance is a square plus b square. This happens only when x and y are normal, are independent. Otherwise there is a 2 times covariance also. So if this happens, it means the covariance is also here. Probability of this happens. Okay. Remember, this is a joint density function. So always remember, whenever you have a joint density function of say x greater than mu, y is greater than of say mu1 and mu2. For example, mu1 is my mean of the x. It is always as 1 over 4 plus sine inverse divided by 2 pi. Now what is the mu? Here is the mean is 0 and 0. So this value is my x greater than 0. Y greater than 0 is my sine inverse rho divided by 2 pi. Now we need a less than sign. So what is the value of this? It is 1 minus of this. Fine. But clearly say this is not equal to 1 over 4. So it is a 3. So this option is also not true. Look at this one. That is a correct statement because it is nothing but my characteristics function. If the characteristics function be written here, it means x and y are my independent. So the B and D are my correct option. Okay, x and y are the bivariate normal distribution. Covariance matrix is given to you. You have to find the mean and variance of this. Okay. Firstly, I can find the covariance. Okay, firstly I can find the mean of, which is the x1 and 5 minus 2x2. So mean is very simple. What is the mean of the x1? 0. I can find the expected value of 5 minus 2x2. This is 5. So the mean is 0 and 5. Mean 0, 5, 0, 5, 0, 5. Now how you can find this? I can return this matrix as here. Fine. Now this value will be variance of x1. What is the variance of x1? 5. This value will be variance of 5 minus 2x2. variance of the constant value is 0 plus 4 times variance of x2. This is my variance of x2, 40. So 5 and 40. He said 20. He said 20. Now you can see about this value. What is that? This is the covariance of x1, comma 5 minus 2x2. Now when you take this value, because the constant value is a 0, if I take this value, it's a minus 2 times covariance of x1 comma x2. Covariance of x1 comma x2 is minus 3. So it is my plus of 6. Now because of the symmetric matrix, it is always 6. So that D is the right answer. Rest options are cancelled. Okay, look at this one. Again, now you can see here F. Clearly say this is the x1, this is the x2. They are not independent. So I can simply cancel. Now you can see what is given to you. Xi follows the normal distribution with of this. Fine. X1 minus x3. It follows. What is the mean of this? Mean is my 0. What is the variance of x1 minus x3? This is variance of x1, variance of x3 minus 2 times covariance of x1 and x3. So variance of x1 is 1, variance of x3 1, covariance of x1 and x3 rho. So it's a 2 minus 2 times rho. Similarly, x2 minus x4 again follows the 0, 2 minus 2 rho. Fine. Now we need a square. So from here I can say x1 minus x3 minus 0 divided by 2 minus 2 rho root. This square will follows my chi-square distribution with the degree of freedom 1. From here x2 minus x4 divided by 2 minus square will follows the chi-square distribution of 1, and clearly says both are my independent. So the sum of them will also follows the chi-square with the degree of freedom 1 plus 1. And you can see if I open this bracket, it's a chi-square of 2 distribution. Now the ratio. When it will be the F ratio, if you x1 minus x2, fine. If I divide it, this number is my chi-square. If I divide it by the degree of freedom, divided by x3 minus x4 divided by the degree of freedom, it will follows my F distribution 1 comma 1. So can it becomes here? Yes, because this value will be cancelled out. So yes, this is my correct state. Moreover, they are independent as well. So that's why we are checking that. In this case, you can see they are not independent. X1 and x1 are same. So this option is directly cancelled out. Okay, look at the first option. Have the identical distribution. If they have the identical distribution, then the mean of each observations are same. Fine. Now we can check about the mean of this. How you can find the mean of this? I can use the covariance property. Covariance of x1 x2 plus E of x1 into E of x2. What is the covariance of x1 x2? It's a rho. Expected values are my 0 because it is 0. So this value is my rho. Similarly for this case, covariance of x2 and x3. This is my x2 and x3. Again rho plus 0 is my rho. This is same. Similarly, because they are identical, each have the same mean, same variance. So this is the correct option. A, C and D are my correct options. Look at this another one. Xi's are my normal distribution. Sigma is the non-singular. Then x3 is my, which of the following is my singular. What is the meaning of the singular? Since the matrix is given to you, a matrix is said to be the singular whose determinant should be 0. So now you can see that x1 minus 2x2, I can substitute x3 value here. So it's a minus, it's will by 5 times x2. So I can return this as 1 minus 2, 0, 5. Fine. So clearly says that determinant is my non-zero, so it is option is cancelled. We can see about here x3 is a minus of 2, so plus x2 twice of x1 twice of x2, so clearly says the determinant is my 0, so this option is the correct option. Look at this one, x1 plus x2, here x3 I can return this number as minus 4 x2, 1 1 2 minus 4, determinant is a non-zero, so this option is cancelled. x1 minus x2, x1 plus x2, so the determinant of this will be 1 plus 1 2, which is non-zero, so the right option is only B is my correct answer. Okay, look at this next one. X follows the normal distribution with the parameter of here. What does it mean? Sigma is my I. B is my real symmetric matrix such that, okay, rank of the B is given to be K and B square is my B. Then X transpose BX, it follows my chi-square distribution with the degree of freedom, rank of the B, that is my K. So this is the correct option. V star distribution is cancelled out because for that case this will follows the V star distribution, but because of the B it is not true. Chi-square, this is cancelled. Now where Zi's are normal distribution, okay, if Zi is my normal distribution with a 0, 1, what is the Zi square? It follows my chi-square distribution 1. If you add them with the K times, then it follows the chi-square distribution with the degree of freedom K times. So this is also the correct option. So the right answers are C and D are my correct answer. You can see, just use the same tips that I told you in the earlier. Xi's are my IID with the mean is my mu, positive dispersion is this. Then which of the following is my central chi-square? Okay, I can firstly find the mean and variance of this. The mean is mu minus mu 0. Variance of this is V of x1, V of x2 minus 2 times covariance of x1, x2. But you can see they are my IID, so this covariance will be my 0. So this is my sigma plus sigma, it is my 2 sigma. The when it will be follows the chi-square, x1 minus x2 minus mean, sigma inverse, this is sigma inverse, and x1 minus x2 of this. Remember, if x follows the multivariate distribution with the mean is mu here, then as I told you earlier, this sigma inverse x minus mu will follows the chi-square distribution with the p. Now in this case mu is my 0, sigma is my 2, so what is that? 2 inverse half x1 minus x2 transpose sigma inverse x1 minus, this will follows chi-square distribution with a degree of freedom, so they are the p variate, so it's a p of this. This is the option only which is the right option. So the right options are D is my right option. You can see within a 10 seconds you can solve the problem. Okay, look at this another one. X is my multivariate normal distribution with the mean is mu, variance covariance matrix is my V. A is my symmetric matrix of order n. Rank is not given to you. Okay, then this is only my symmetric, fine, but remember the first option is x transpose AX. This will follows the chi-square, but we need A to be a positive definite. There is a first or second question where the certain options are discarded. Moreover, so this option is cancelled out. Moreover, because this simply say idempotent, but here this is the x, but the mean is my non-zero. So what is that? This is my non-central, because we are not subtracting the mean. This is a non-central chi-square, but he said central chi-square. This option is cancelled. X transpose again is a central, but its mean is non-zero, so this option is also cancelled out. X transpose is a central chi-square, again this is a cancel. So only option is my third is the right option. And moreover, we already explained you if this is my quadratic form, then the mean of this quadratic form is A trace of this into this plus mu transpose of here. So what is the sigma in this case? Sigma is nothing but my mu v, sorry, sigma is my v, so it's a AV. So you can see it's a AV. A transpose is the right answer of this problem. Look at this another one. Y follows the normal distribution with the n variable 0, I. So it means sigma is my I. Fine. A and B are my symmetric matrix and idempotent. Means A square is equal to A, B square is equal to B. This is given to you. Then independent. Okay, so as I told you, this and this, when they are independent if and only if A sigma B should be 0. Fine. So what is the sigma in this case? This is the I. So once this is I, this implies AB is equal to 0. So if AB is equal to 0, then because this is if and only if result, this hold. If A plus B y times of this then are independent, again same result hold, because moreover if y transpose A plus B of y will follows the chi-square distribution. What does it means? A plus B is my positive definite. Fine. If A and B are my positive definite, it means y transpose of A and y transpose of B is my chi-square distribution, and because of this is also the independent here. And this is again same by using this same property, because x and y are independent, or this is a chi-square distribution because the mean is my 0. You can see I can return this number is sigma of y, or if you return this in terms of A, it follows the chi-square rank of the A. The difference is also the chi-square distribution, but it is a non-central chi-square distribution, but here is a 0, so it's a chi-square, so its option is cancelled out. So right options are A, B and D are my right answer. Always remember the difference of the two chi-square is a chi-square, but it's a non-central chi-square distribution. Okay, xi's are my standard normal distribution with the k parameters. If A is my idempotent k cross k matrix, then I minus A and here. Always remember, whenever A is my this, as we have discussed in the linear algebra, what does it means? Whenever A square is equal to A, that means trace of the A and trace of the I minus A are same. Rank of the A, rank of the I minus A are same whenever you have a idempotent matrix. Now you can see whether they are in the fine. So what does it means? X transpose AX will follows my chi-square distribution. X transpose I minus AX will also follows the chi-square distribution. And since they are idempotent, when they are independent, when A sigma I minus A should be 0. Now you can see that sigma is my identity. So what is that? This is A, I minus A is my 0, and you can see this is nothing but the same. So this property is satisfied, hence this is the correct option. This and this are identically distribution if k is my even. So we can see from here, trace of A, if I open this, it's my k cross k matrix, it's my k minus trace of A. So what is that? Trace of A is nothing but k by 2. So which is same. Half of this x transpose ax will follows my chi-square distribution with the degree of freedom is say k or the rank of a, and when you multiply with the half is a constant quantity, then it follows my gamma distribution with the parameter whatever the degree of freedom into half of this value. Fine. So it is a gamma distribution. That's a fine state. This will follow the chi-square distribution if a is not equal to I. Definitely if a is equal to I, it's a non-zero, it's a 0. So this option is also correct. A, B, C and D are the correct options. Okay, look at this one. Phi is the density of the bivariate normal distribution. Mean is given to be here 0. Okay, and the density function is there. I consider f is a density function of phi. It is given as half of f1, half of f2. So I consider f1 is the density function of the x, f2 is the density function of the y. Then the marginal density function of this. What is that? This is a linear combination of the f1 and f2. Fine. Now, marginal density function of this. Okay, fine. Because it's a bivariate normal distribution. If x and y, no, phi is the density function of this. Phi is the density function of the bivariate normal distribution and it's a linear combination of this here. What does it mean? f1 and f2, that is the corresponding vectors, are my standard norm. That's the by definition of this problem. Covariance. Covariance. So I can apply the expected value of xy minus, fine. This is the need. So since expected value of the x and y are my 0, so this value is my 0, so I need only xy. Now this is the definition of covariance. Fine. Now look at that. If I apply the expected e of xy on this case, what will happen? So if I use this property half, this is expected value of xy for the distribution 1 f1 plus expected value for the here. Now what is that? In this case, rho is my half. So for this case, 1 half half 1. And what is the covariance of this? What is the expected value of covariance of this? Is half. This is my covariance. Similarly for this case, it is my minus half. So 1 minus half. So again this is my covariance of half, which is to be 0. Fine. Now look at the third and the fourth option. Okay, so if f1 and f2 are marginal normal distribution, so it means this is root 2 pi x square by 2. Marginal distribution of y is here. Fine. Then when it's said to be the independent, when if you multiply them, it should be f of xy. So let's see, this is half of x square plus y square, but you can see this is a row which is a non-zero for the journal. So which when you multiply them, it is not equal to this case, because you all know this value should be 1 over root pi 1 minus this half x minus mean square and so on. But here rho is my non-zero, so that's why this option is cancelled. Look at the last option. So as I mentioned in the tips, if x and y are my jointly normal distribution, then covariance of xy 0 if and only if xy are independent. But we already say they are not independent. It means they are not jointly jointly means bivariate, because they are the two variable. So this option is also cancelled. A and B are the right answer. Look at this another one. If here let xi is this. Okay, so xi follows the normal distribution with a mean and variance. Y of 2i's and this, then Z transpose. What is the Z transpose is? Y1 y2, y of 2n. Okay, so my target is to check when it's said to be the multivariate. If I prove this is my positive definite and symmetric matrix, fine. Now my target is to find the variance of y1. What is the y1 here? Variance of xi cos theta. Cos theta is outside. What is the variance of xi? Sigma square. Fine. Sorry, if it's a constant value, if I take outside, it's a sigma square. What is the covariance of y1 comma y2? y1 is my here, y2 is even number, which is written this. So if I substitute, cos and sine is my outside, rest part is covariance of x1, x2, and they are independent, so this value is my 0. So y1, y2 is my 0. Similarly, y2, y3 is 0, and last value is also 0. This is sigma square cos square. y2, y1 is 0. What is the y2, y2? Variance of y2. y2 is my, in this case, it is my sine square. Variance of xi. So this value is my sine square, sigma square, and rest are my 0. Similarly, last case, this is an even number. It is my sine square, sigma square. So clearly say this is the positive definite because the diagonal numbers are always greater than 0, and it is a symmetric as well. So the first option is correct option. Now look at this another one. There exists a C such that Z into Z transpose. Sorry, Z transpose into Z. So Z transpose is my here. If you multiply this by here, it is y1 square, y2 square plus y of 2n square. Fine. Then it's a chi-square. So I need to find the distribution of yi. So what I can do, I can find the distribution of this. This is my here. What is the mean of this? Xi has the mean this. What is the variance of this? Cos square into variance of xi square. Fine. What is the this distribution? Mean is 0, sine square and sigma square. Fine. So from these two cases, I need to find the yi square. So it's a square. So y2n minus square. Sorry, it is minus 0 divided by cos into root. This follows my chi-square distribution. And from this case, y of 2n square divided by sine theta and sigma, this will follows my chi-square distribution. Now you can add them. If you add them, what is that? It is 1 over sigma square is a common, cos square, sometimes sine. Okay, there exists a C. C is my constant. Can you find when it will be the constant? When they are same. Cos theta is sine theta, then only you can take it as a outside, then only it will be here. So when it will be here, this will be pi by 4, and pi by 4 is lies inside it. So when you take theta is pi by 4, it is my 1 by root 2. So sigma by root 2, or you can say it's a 2 over sigma is my outside. Y of 2n square. Now it follows my chi-square distribution. So yes, this option is correct option. Look at the last third option. Now your target is to prove y v transpose. What is the v is? X1, y1, x2, y2. So basically this is the combination of x and y. Fine. Or y I can return as a combination of the z. So this is basically a here. Then your target is to write the covariance matrix of this. Fine. So what is that? This is my is a variance of x. So what is the variance of the x? It is my sigma square. Fine. Because z I already defined that it's only the diagonal entries. So it's all elements are my 0. So this the covariance is also 0. This is the variance of Z. So clearly says again this is a symmetric matrix and positive definite because this number is my positive. So yes, this is a multivariate normal distribution. Now V transpose of V less than, okay, since V transpose V is my quadratic form, fine, so then we can find the expected value, so we can apply the Jensen inequality, fine. It clearly says a convex function, so it is less than of expected value of this, fine. V transpose of V is my like x1 square plus z1 square and so on, which follows the chi-square distribution, so which is a finite number. Why? Because expected value of this V transpose of V will follows my chi-square distribution, so this has a greater than 0. So once is a greater than 0, it's a finite number. So all are my right answer of this problem. Okay, look at this another one. X1 and X2 follows a bivariate normal distribution with a common marginal distribution. That means X has distribution function Y, F, Y has a function this, and the correlation between X1 and X2 are my 0. What this means is covariance of X1 and X2 are 0, but it doesn't mean they are independent. When they are independent, only when you prove X and Y are my bivariate, jointly bivariate normal distribution, fine. Now look at the definitions. Firstly, look at the fourth option. If F follows my normal distribution, it means F of X is my normal distribution, F of Y is my normal distribution. So as I told you in my previous example, what is the PDF of this? 1 over root pi x square by 2, which is F of Y, but F of X into Fy is not equal to F of Xy, so that means they are not independent. If X and Y are my uniform distribution, so PDF of this is half, PDF of Y is also half, so clearly says F of X into Y is not equal to 1 over 4, because if they are the joint distribution, then it will be 1 over root pi 1 minus rho square E of this, which is not equal to 1 by 4. Now if it is a Bernoulli, of the single parameter, because Bernoulli has only the single parameter, so this has theta, which is same of this case, fine. Then if you multiply them, yes, 2, okay, I can think about this third option. Now look at the third. If X and Y are the discrete distribution, minus 1, 0, 1, and say this is a P1, P2 and P3. What is the mean of this? Is minus P1 plus P3. Now clearly says that's again true. F of X can be any discrete distribution. It may be binomial. F of Y say is a binomial, but F of X into Fy is not always be the binomial. Product of the two is may not be there, so this option is also cancelled, because this is only the single parameter. So that's why they are jointly bivariate distribution. If they are jointly bivariate distribution, covariance implies independence. So the right answer is B is my rest. Okay, look at this another one. Okay, now your target is to firstly correlation of x square y square. Okay, before that I will tell you the simple shortcut tips. I can define this is say covariance of x square y square divided by variance of x square, variance of y square, fine. So remember, if there are several methods, but if you remember that if x and y are bivariate distribution, then this value will be my here. Why I use? Because if I open this bracket, I needed this value x square y square minus Ex square Ey square. Fine. Divided by variance of x square is Ex square minus Ex whole square. Similarly for this case. Now, if I look about this, sigma 1, 1, sigma 2, 1. 1 into 1, 1 plus rho is the covariance between x and y. It's a rho. Fine. Minus E of x square. I can use the variance. Mean is 0. So what is the E of x square? Variance of x. So that's a 1 into 1. So the numerator part will be 1 is a 2 times rho square divided by E of x square is 1. So this is a 1. E of x square. Sorry, variance of x square. It's a variance of x4. It's a variance E of x square. So what is the E of x4? Since it follows the normal distribution, so again I can use this value into sigma square. So it's a 1 into 3, sigma square is my 1. So this is my 3 minus 1 square. Again 3 minus 1. So it is my 3 minus 1, 2 into 2. That is sigma square by 2, sigma square by 2 is sigma square. First option is correct option. Fine. There is one more method. Instead of using this, if I found E of x square into y square. If you are not remembering this formula, then again by using the conditional distribution, I can return this number as E of x square y square condition x. Fine. Now I can return this number as E of this value. I can return as x square is outside, expected value of y square condition x. Now we all know if x follows the normal distribution with the mean x, variance y, y follows the normal distribution with the mean y, sigma of this, then y over x also follows the normal distribution with the mean m. What is the mean is mu of y plus covariance divided by sigma of x square into x minus x bar, and the variance is 1 minus rho square of sigma y square. Now you can see what is that, because mean is my zeros, so this value is 0, this value is 0, variance is my 1, so covariance is my rho. In this case it will be my rho into x, and this value will be my here. This will follows my normal distribution. Now we need the y square. How you can find the y square? I can use the concept of the variance. Variance plus expected value of square. Fine. Now you can open this bracket. 1 minus rho square is outside. This is x square plus rho square outside. It is x4. So what is that? It's a 1 minus into 1. It is a 3 times sigma square. Again you can see it's the same you can obtain like here. But if you remember the shortcut tricks, there is no need to solve like here. Okay, look at this second option. Again you need to find the, okay, firstly you can check about here x square z. Now if you look about this option, x and z, this value, fine. What does it means? X and z are my independent. Fine. Covariance 0 doesn't mean the independent, but it's a jointly normal distribution, so it's a independent. It means x square and z square are also independent. Fine. So if they are independent, it means the covariance of x square z square is my 0. If covariance is my 0, then the correlation between them is also 0. Fine. Anyhow, I can use, instead of this, I can use again the same formula. What is the covariance of x square into z square? It is E of x square into z square minus E of x square E of z square. What is the E of x square z square? Sigma 1 square, sigma 3 square, 1 plus 2 times of this. What is the sigma 3? Variance 1, 1. Sigma is a 0, so it's only 1. E of x square is 1, this is 1. Again we can see 0 is the right answer. Now look at this second option. Second option is, again we can find the firstly covariance. Covariance is E of x square into y minus ex square into ey. Ey is my 0, so it's my 0. Again, how you can solve this? I can again apply this expected value property, x square into y, condition of x. So it is E of x square into expected value of y condition x. So what is the y condition x? Expected value of y is rho of x. So this is rho of x. So covariance of y and x is my rho. So it's x cube, and x is my normal distribution, so odd term is always 0. So once the covariance is 0, it means the correlation is also 0. Look at the last option. I can open this as a, it means it's a covariance of x square comma y square plus z square. Fine. Now I can written this is covariance of x square over y square plus covariance of x square over z square. Covariance of x square is my rho square. This value is my 0. This is my rho square. Now I need to find the variance of x square and variance of y square plus z square. So how you can find the variance of x square? So I can see this E of x4 minus E of x square. So this is my 3 times sigma square. This is my 1 times sigma square. So what is that? It's a 2 times sigma square. Sigma is my 1, it comes to be 2. I can find the variance of y and z. So y and z is y square plus z square. Variance of y square plus variance of z square plus covariance of y and z. Covariance of y and z is 0. So because x square is my 2, so it is also 2 plus 2 is 4. So I can divide it by x. 2 plus 2 is 4. Clearly say which is not equal to, no sorry, covariance is my twice. I derive this covariance is my twice. So again it is my not equal to rho square. So this option is cancelled. A, B, C are the right answers. Okay, now the next category is my principal component. A very simple category. Always find the eigenvalues of this matrix. Now you can see how you can find the eigenvalues of this. There are the two methods. Firstly, you can find this value. Otherwise, you can break them here. Fine. So now these two are 0. So one eigenvalue is my 4. Now it's a 2 cross 2. So you can write as a sum of the diagonals plus determinant of this 60. So clearly say it's a 10 and 6. So eigenvalues are my 10, 6 and 4. Then what is the percentage of the variation corresponding to the first principal? First principal eigenvalue is always with the largest eigenvalue. So largest is 10 divided by total. Percentage is 100. So what is that? 10 over 20 into 100 is my 50 is the right answer. Okay, look at this another one. 3 variate, which of the following is my proportion principal are there. Again, I can find the eigenvalues of this. I can take sigma square as a common. 1 rho 0, rho 1 rho, 0 rho 1. So since none of them are 0, so I can find the A minus lambda I. This 1 minus this. Fine. So if I expand them, it's come to be 1 minus square minus lambda square minus of this rho of 1 minus this. Fine. So what is that? I can take 1 minus lambda is a common. 1 minus of this minus 2 square. So what this means is one is 0 and other is plus minus root 2. So what is the largest eigenvalue is 1 plus root 2. Next value is my 1 minus root 2 and third is my, sorry, it's a 1. Then second value is my here, third is my this. Fine. Now look at that. What is the value of this? Because they are the eigenvalues. For the principal component, each eigenvalue must be greater than 0. So clearly says this eigenvalue is greater than 0. It means the maximum value of this should be here. The proportion of the total by the first component, the largest value is my here, divided by the total is my 3. So which is not same. The proportion of the total variation explained by the first two component. The first two is the first largest, second largest. It will be my 2 plus divided by 3. So clearly says it's satisfied. Now look at the last concept. The second principal component. In the principal component analysis, all the principal components are orthogonal to each other. Fine. So the second principal component is if orthogonal to each other, it means they are dot product is 0. That means they are uncorrelated. But need not be an independent. It's uncorrelated. Is a correlated with the first and the third component. Is the right answers. A, C, and D are my right answers. If xi's are my normal distributions with the mean is mu, then the coefficient vector Li of the first principal component means if I return this value here, what does meaning of this L1? So since corresponding to the first, it means this is my largest eigenvalue. The vector of all eigenvalue wrong. Eigenvector corresponding to the smallest eigenvalue wrong. Eigenvalue corresponding to the largest eigenvalue correct. Vector of all the eigenvalues, all, not all, only the largest eigenvalue. If X is my p-variate normal distribution with the variance covariance is my sigma, mean is not given, so I consider as a mu. If pi's are my orthonormal eigenvectors corresponding to the eigens values here, then fine. If p1 here, the corresponding eigenvalue is this, corresponding eigenvalue is this, then what are my principal components? Principal component is lambda I p transpose, or these are my eigenvalues. Fine. The principal components are my eigenvectors. So how you can find the eigenvector? That's a simple p transpose of x. The first principal is corresponding to the p1. So p1 transpose x. Fine. p1 transpose x is the first principal component. p2x is my second principal component, and each principal components are my orthogonal to each other. If they are orthogonal to each other, it means they are uncorrelated to each other. But he said it's a correlated. This option is cancelled. As I mentioned you here, they are my uncorrelated. So but he said it's a correlated, cancel out. The sum of all those eigenvalue is nothing but the trace of this. Find what is the variance of p of I. It is same as of lambda I, but it's a p1 is a lambda 1 is a correct option. So A, B and D are my correct options. Okay, look at this another one. If PIs are my multivariate normal distribution with mean here and this, eigenvalues are my 6, 3, 2 and 1. YIs are my 4 principal components. The percentage of the variation of the first two components, first two largest value 9. What is the total is 9, 10, 12. This is my percentage. So what is that? 3, 4. So that's my 75%. 75% less than 95, correct option. The percentage of the first three component. So first three component is my here. 11 over 12 is here, which is less than of the 95%. It's a 91 point something. But what is that? It's a 91 point something, but it is 90 greater than of this is the wrong option. Look at this another one. YIs are independent. So principal components are independent. When the principal components are independent, remember, if the variable called as the original variable, nor the principal component, means xi, if the original variables are jointly normal distribution, then the principal components are my uncorrelated, means covariance 0. This implies principal components are my independent. Whenever there is a jointly normal distribution, the uncorrelated implies if and only if independent. So because you can see it's a multivariate normal distribution jointly, so they are independent. Identically, we can't say anything about the identically, but independent we can say about using this result. Fine. So this is the simple result of here. Look at this another one. You have to find the percentage of variation by the first principal component. You can see there is no need of this. I can see here the one eigenvalue is my 2. For this case, sum of the diagonal and determinant plus 9 minus 5. Remember, whenever you have the A, B, C, D, you can write the equation as A plus D and determinant of this AD minus BC is a 0. So from here you can find the eigenvalues as 1 and 5. So your eigenvalues are 5, 2 and 1. By the first largest value, this is my largest value, so answer is 5 over the sum of this 5 plus 2 plus 1 into, so 5 over 8 into 100, 4 to 425, 125 over 2, 62.5 is the right answer of the problem. So this is the way you can solve all those components in a very simple manner. So we will see the next lecture on the Wishart distribution. Till then you can simply scan and join my WhatsApp group of the statistics, especially on the statistics. I hope you can like, share and comment on my video. Best of luck students. Happy learning.